Hi, this is Alex Wood. I'm doing my calculation for the Conservation of Energy project. I'm going to be finding the velocity at the top of a hill. First, we need to find the total energy of the roller coaster. To find that, we need to plug in the potential energy equation, which is mass times gravity times height. For that, we plug in the mass of the marble, 5 grams, the acceleration due to gravity, 9.8 meters per second squared, and the height at the top of the roller coaster, 1.69 meters, which is equal to 82.81 joules. We know that the kinetic energy at the top of the roller coaster is zero because it is not moving. It is the start of the roller coaster, the highest point. So 82.81 joules is also the total energy. To find the velocity here, we then find the potential energy at this point, which is 5 grams, the mass again, 9.8 meters per second squared, the acceleration due to gravity, and 0.41 meters, the height at the top of the hill, which is equal to 20.09 joules. Then to find kinetic energy, we do the total energy of 82.81 joules minus the potential energy of 20.09 joules to equal 62.72 joules, which is the kinetic energy at this point. Then for velocity, we do the square root of kinetic energy over 1/2 mass, which looks like 62.72 joules over 2.5 grams, which is equal to approximately 5 meters per second. Thank you for watching.